Abe Gong, CEO and co-founder at Superconductive. Welcome to the Data Exchange podcast.
Thanks, Ben.
And Abe, as I was preparing for this conversation, I noticed that actually a lot of your background is in health. So you were at a couple of health-related startups, and then actually I think the original name of the company was even Superconductive Health, right?
Yeah, that's right. I definitely have an affinity for healthcare, kind of human-centric data.
So what was the genesis or origin story of Great Expectations, given that I imagine you guys were doing superconductive health at the time, right?
Mm-hmm. Yeah, you can tell the story from a couple different directions. Let me start from superconductive. Like you said, we started as Superconductive Health. The goal was to consult into a product in healthcare analytics. And I could talk more about that, but that's turned out to not be what we're doing. As part of
And
that, we were
that was kind of a extension of what you were doing at Jawbone, kind of similar.
Yeah, if you want to
Similar.
think of it that way.
Yeah.
Yeah, I mean, there's a lot of really interesting stuff going on in healthcare data these days. With Superconductive Health, we were doing consulting projects for data warehousing, analytics, some machine learning, with domain expertise around healthcare specifically. And part of what we were kind of showing the world there is a lot of healthcare is built on very old data infrastructure, and a lot of really interesting things have happened in even the last 5 years. But there's a lot of healthcare systems that were built in the 80s or the 90s, and so as business models and like the way care is delivered.
It's a huge industry too. Huge industry.
Yeah, it's a huge industry. Yeah, there's a lot going on there.
Yeah.
So anyway, without going into all the details, it was pretty clear to us that we needed some notion of data quality and data testing. And from background at Jawbone and other places, we knew that nothing like that really existed in open source. So we thought that we were filling this need that we could use as part of our business, and that might also be helpful to the rest of the world. And that turned out to be right, I think with emphasis on the rest of the world. Because over the course of a couple of years, the open source project outgrew the original vision for the company. And as of last year, a year and a half ago now, we pivoted, and now Superconductive is no longer Superconductive Health. We're focused exclusively on building Great Expectations as an open source project, and then eventually building a commercial layer on top of it.
So if for those of people listening who aren't familiar with Great Expectations, so what was the original idea behind Great Expectations, and has it adhered to that original idea?
Mm-hmm. Yeah, I'd say it's adhered and expanded. So when you hear Great Expectations, I think you should hear two things. One is it's an open source project. And the project itself allows you to do data testing, data documentation, and data profiling. And I can talk more about how those concepts are linked.
You might as well explain to people what you mean by those concepts.
Okay, let me come back to that in just a sec, because in addition to the project itself, there's also the community. So more than 100 people have contributed to Great Expectations. That number is actually starting to grow pretty rapidly. And if you go to the public Slack channel, there well over I think we're approaching 3,000 people there. So just this large community of data practitioners, some data scientists, some data engineers, some data analysts, all collaborating together on figuring out how to really make data quality work for them.
And so why is data quality? I guess data quality is important because it's garbage in, garbage out, right? So, but what exactly is a data quality tool?
Yeah, and this actually goes back to your earlier question about kind of like, what does the product do?
Yeah.
I think we originally conceived of it as data testing, with the notion that in the software world, if you build complex systems and you don't test them, you just know they're going to break. And ever since CI/CD became a thing, 15 years ago, plus or minus, like that's just been table stakes for serious software engineers. So we saw ourselves as enabling the same kind of thing for data engineering and data science. There's one twist, which is in the data world, code changes, but data changes much more frequently. And as a data scientist or data engineer, you usually don't control all of the inputs to your system. And so the way Great Expectations is written, you can use it to sort of wrap pipelines and tests as the code changes, but it's actually usually more important to test the data as it changes. So the fundamental concept is an expectation, which is an assertion about how data should look or how it should work. And that can be everything from schema checks, so like what type is it, or like what are the column names, to the contents of cells, so matching regexes or fitting within certain ranges. Then from there, you can actually build up pretty complex vocabulary of things like correlations, relationships among columns or across tables. Like, for example, a very common one is to assert that the row counts between various tables don't deviate by too much. So, as I go from table A to table B, it's okay to lose a little bit of data in transformation, but at the end of the day, I should have 98% of the same number of rows.
So how do you enumerate or write down assertions?
When you say how, you could actually attack that question at several levels.
Oh, so I mean, so is it Python? Is it in a YAML file?
Yeah. Yes. So the library is built to support these declarative expectations. The main orchestration happens in Python, but the actual execution happens wherever your data lives. So, for example, if you're working within Snowflake, there'll be a thin Python layer that essentially compiles your expectations into queries that execute in Snowflake. And then we have the same thing for many SQL dialects and Spark and Pandas.
But right now, the assumption is it's either data scientist, developer, or engineer. Because as you know, Abe, in many instances, people with the business knowledge actually know the data best, right?
Mm-hmm.
So
Yes.
how do you work in human knowledge?
So that's one of the really fun features of Great Expectations. I said before, we do testing, documentation, and profiling. The way Great Expectations is set up, all of your tests can be compiled not just into queries, but also into documentation. And so that can be data dictionaries, it can be a lightweight data catalog. We also allow for things like after you validate data, you could generate Slack messages or emails. We've heard some fun stories about teams where they have data vendors who don't always send them correct data. And so you could actually ghostwrite the email back to your data vendor, right? Hey, we've got this month's data. We looked at it, meaning we ran it through automatic validation, and we noticed some discrepancies in column X, Y, and Z. Here are some of the offending rows. Can you help clarify what's going on? So it's a really interesting thing to have this strong compatibility between the way the data is documented and the way it's tested, because, well, as an engineer, it frees you up from having to maintain kind of two things in parallel, like your data wiki and your data tests, your data pipelines. As a non-engineer, it's actually really cool because it provides a very direct way to see exactly what's going on inside the data without having to be fully fluent in Python or SQL or YAML.
So to what extent is the stuff we're talking about, it's mostly structured, or is some of these ideas starting to creep into the unstructured data realm?
Good question. Most of Great Expectations support is for tabular data. We do have some support for file formats themselves. So when were things updated? What's the suffix? What's the size? Checksums, things like that. They can often be good kind of pre-flight checklists before you even try and ingest into a data warehouse or a Spark cluster. We have had some people do like interesting early work around expanding into nested data like XML and JSON. And I've also seen some people working on image data, thinking of those as large matrices. So the concept of an expectation and this notion of kind of needing quality checks, I actually think that's a pretty universal concept. And in the long term, it'll go to many places. in terms of where does most of the business value live initially, it's mostly tabular. So that's where we started.
So, as our listeners know, so I'm an advisor to Databricks, and I've also and I continue to do some consulting work for them. So I'm somewhat familiar with data quality in the context of data pipelines. So yeah,
I know you are. I think you're underselling it there.
Yeah. So to what extent? So here's so I think Abe, as I mean, as much as we talk about I think most of the world actually lives and dies because of data pipelines, right?
Mhm.
I
Well,
mean,
the supply chain for AI, right? Garbage in, garbage out.
They're the ones that really, if they break, then you're in trouble, right?
Mhm.
Yeah, so there's certain things that that make pipelines challenging, as you know, and I think the tools like Great Expectations are actually great for data pipelines in general. But I mean, so for example, developers need to be able to catch data quality early on, and in production, they need to be able to test their pipelines. I mean, if it's multi-stage, maybe even test it locally. So I think Great Expectations is great because you can start thinking of unit tests for pipelines, right?
Yes. Yes. I mean, when you see how people deploy Great Expectations, I'd argue kind of three main patterns. One pattern is monitoring data at rest, which would be looking up tables or parts of tables
Like in a data warehouse, pointing it to a data warehouse or something.
Yes, or logs in Azure Blob Storage or S3 or something like that. So those are both, you set up a cron job, you look at it every once in a while, you make sure that whatever has arrived is what it should be. And that's helpful for defending downstream systems against it. If something's wrong, of course, at that point, it's already broken in your data warehouse, your logs, and so you do have to go back and fix it. Second option is to go upstream of that into the actual processing system, which might be Pandas or Spark. We see a lot of Airflow deployments around Great Expectations. DBT is another good example here. And for that, you can run the checks inline and actually use them as a way to stop the propagation of bad data when the job is running. So that gives you some additional affordances for defending your system.
So
and then, like you say, you can go even further upstream and test the code itself before it's in production.
So let's say, I mean, in a world of complex systems, I think it's unrealistic to think that your system is not going to fail. It will fail at some point, right? So failures are inevitable. So in many ways, your goal should be to always minimize your mean time to recovery from failures. So to what extent, Abe, have you seen Great Expectations help in this regard in terms of helping people chase down bugs and problems?
That shows up at several levels. I mean, there's kind of the level of the individual developer just finding something. One thing that we see pretty commonly is the place where Great Expectations delivers a lot of value over time. And I think this isn't just us. I think this would be most data quality systems. It's actually at the boundaries between teams. And the reason for that, I think, my theory of the universe is within teams, you usually have a pretty good grasp on the complexity that you're managing and the nature of the business logic there. It's actually much more common to have somebody make an upstream change that doesn't break their own system, but inadvertently breaks somebody else's downstream system. And so the place that Great Expectations then becomes really helpful is as sort of a contract across team boundaries to make sure that there's an SLA for data quality where everybody understands it in the same way. I think for a long time, there's been this concept of data exhaust and, we're just using somebody else's exhaust to build our machine learning models or our dashboards. And that's good as far as it goes, but I don't know, if you get into the economics of it, whenever there are positive externalities, the thing is always underproduced. And in this case, I think the thing that's underproduced is not data itself, but quality data.
Yeah, and actually, as you were talking, so one of the things that makes pipelines tricky, just like ML, but even maybe more so. So first of all, both of them involve code and data. But in the case of pipelines, you're actually usually talking about multiple systems, several of them might be distributed. So there's a lot of complexity. So to the extent you can inject some rigor and ensure quality at each stage, you're better off, right? So.
Oh, totally. Yeah. I think one of the things that's pretty unique about Great Expectations is we've set it up so that it can bind to lots of different systems, right? Like we want it to be this meaningful, semantically meaningful layer that sits on top of lots of different architecture, lots of different infrastructure, so that as data crosses all of those boundaries, everybody can know what to expect of it.
Oh yeah. So then the other, it just occurred to me, one of the other things about pipelines is side effects, right? So you imagine you're trying to test out your pipeline, but you can't really do it completely because it's writing to all these systems. Just so many things that can happen. So you really need to inject as much rigor as you can as you're building these pipelines, particularly if the pipelines involve multiple teams and impact downstream applications, right?
Oh, absolutely. But I will say, I think the world is moving away from side effects. I think it's not always possible to completely get rid of them. But when you look at the architecture of Airflow 2 or any of the kind of newer tools like Dagster, Prefect, or Flight, they're all working very hard to maybe not eliminate the concept of side effects, but be disciplined about when they're allowed to happen and surface them appropriately.
Yeah. The notion of loose coupling, right? So, yeah. So we'll be remiss if we don't mention, Abe, that there are other data quality open source tools, but maybe not as broad as Great Expectations. So, to what extent do you, for example, look at projects like TensorFlow DV as being in the same realm? Or I guess there's another project called Assert R, right? So,
yeah, we actually drew inspiration from Assert R early on. And I think not everything about the projects is the same, but there's a lot of comparable things. I think anywhere where you are in Python or Spark, we're pushing to be a universal DSL there. It doesn't mean that you can't also translate back and forth to something like TensorFlow. But I think there's real value in having something that spans systems, not working uniquely within it. So TensorFlow DV, it's a good tool if you are strictly within TensorFlow.
Right.
But if you want to share across those borders, less helpful.
Now there are suddenly a slew of startups who are in the data quality category, but they're not necessarily doing something similar to TensorFlow, to Great Expectations, right? So some of them are literally just looking at quality in a warehouse, for example.
Yeah, in fact, most of the ones that I've seen so far are mostly looking at quality in the warehouse. There are smart people at all of those companies, and they'll do cool things. But.
Yeah, there's nothing wrong with that because data warehouse market is a huge market, right? So,
yeah, I think the place where we're differentiated is really two things. One, this notion that we want to be not just an engineering tool, but a communication tool that works across team boundaries. And that two, in the process of doing that, as open source, we want to make sure that the developer is always in complete control of the experience. And that means that some things like sort of automatic anomaly detection, for us, we're taking a longer route to that to make sure that, like, yes, you can profile your data and get out good reports and generate expectations from that. But our rule is, in the process of doing that, you just cannot possibly let that become a black box.
So this is probably an unreasonable question to ask if you haven't conducted the survey. But what is roughly what is the demographic breakdown of users? Does it skew more data engineers, developers over data scientists?
So I don't know off the top of my head. The thing that I'd say is I actually think that the nature of those roles is evolving, and that the thing that we've identified as our sweet spot is developers who sit at the intersection of two things. So one is they understand what the data means. So they're plugged into, to some extent, they're domain experts, and they might not be the expert, but they've absorbed a lot of knowledge about how this data works, how it's intended to function, what it means for the business, and so on. And then they're also concerned with repeatability, which might be full-on data engineering in the sense of building pipelines that need to run completely unmonitored. In some cases, it might be something lighter, like
And also
building.
have SLAs maybe.
So that's actually where I wanted to go.
Yeah.
Yes, but not always. So you'll see a lot of teams where they have, for example, a folder of notebooks that get run on kind of an ad hoc basis, once a quarter or once a week.
That is scary, man. Folder of notebooks.
Yeah, and a lot of the data world works that way, right? I mean, I've been there, like the notebooks break, it's like, right? And if you said like, well, everything that you build as a data science team or data engineering team must have an SLA, must be buttoned up, like the cadence of development would go so far down. So there's this interesting kind of gray area where it's not fully production code, but it is repeatable, it is hardening over time. And yeah, a lot of great expectations users live there, and within the full kind of fully baked SLA stack as well.
So what about
repeatability and domain knowledge, like those two things together?
So what about batch versus real time? What's the breakdown?
Mostly batch, although a lot of the data originates as real-time data and gets passed through. We haven't yet built great integrations to things like Materialize and Kafka, although we know that people are doing that within the community. And if any of your listeners are doing that and have like, I know that a few of these projects exist around Great Expectations, we would welcome contributions back to make those integrations, because it's a natural direction to go.
So you said tabular data, but there's another group of structured data that seems to enjoying a renaissance: graphs.
Mm-hmm.
Have you guys
we've been asked about it a few times.
Yeah.
We've not done any concrete development in that direction. And yes, like I could definitely see where that would go. Like CTO James at the company has a fair amount of experience with graph data, and every once in a while he raises it like, hey, is it time for us to do graphs yet? So not yet, but with the right partners, we definitely go there.
And what about you said semi-structured? So there's like semi-structured text that expects a certain number of fields and formats.
We have some of that, like I said, in the the file format data. You can do things like assert that this number of pipes or this number of commas exist in a row. We're also seeing, like, we got a cool, I don't know if it was PR'd all the way in, but there was a cool community contribution a few weeks ago that said, expect column text to be in language. And it's just character trigrams, I think. It's using some machine learning light to check what the language is in a given text cell. So the vocabulary you can express gets really broad and really interesting there.
By the way, so if let's say, I have data, I want to upload it to a data exchange or a data market, I should run Great Expectations, right? So why should I sell?
Oh.
Why should I should QA the stuff that I'm going to sell, right?
Oh, totally. And you should ship it with the data dictionary and with the attendant texts. This is a thing that we're starting to hear people ask for. We haven't done any kind of big public push around, but from the perspective of data sharing, yeah, this is a technology that should make those things much easier.
All right. So Great Expectations, as you said, is an open source project, and it's grown. So couple of questions that I ask open source project leaders. The first one is, what are your key metrics beyond GitHub stars? So what is the team monitoring? So
we watch Slack users pretty carefully. If you join our Slack channel, you'll see a bunch of kind of automated onboarding. So there's a light survey that just asks, what are you here for? How can we help you? What would you like to see in the project? We try and do at least a best effort for personal touch follow-up with everybody who joins. So yeah, people joining the Slack channel and then just making sure that they're served well when they come there.
So you guys don't look at metrics like number of downloads, contributors?
We track contributors until just a few weeks ago. Actually, it wasn't a thing we were focusing on.
And admit it, you track GitHub stars too, man.
Oh, I mean, everybody tracked. You get those for free, right? But what does a star mean, really? Right?
I don't know, but VCs track them, right?
I think so. I think for us, we've reached the stage where stars alone would not do it. Like you need to see that it's getting used by real companies in real places. So,
so a question about Slack. So I've talked to other open source communities about Slack. So I guess unless you have the paid version, a lot of that knowledge disappears. It's hard to search. So,
you have been following this closely.
Yeah. So there are people who are trying to build better tools so it's searchable and also persistent. So what are you guys thinking about in terms of all that body of knowledge that is in your Slack?
We middle of last year started encouraging people to post questions to Discourse or in some cases Stack Overflow. That's been helpful. Candidly, I don't know that it's a perfect solution. There's always some friction going from a conversation.
So what's the argument? So Abe, what's the argument for not going full on Discourse, and why retain Slack?
The real timeness of it is a big deal. Just being able to chat and get immediate answers. I think just as people, we're wired for that kind of social interaction. It just feels more tangible. But then that said, we have looked at Discord, and that might be a possibility.
So that real timeness, I think I've also talked to some open source people who actually resent that real time. Because basically there are one or two people, and then they just get overwhelmed, right? So, and then they decide, okay, this is not a good use of our time because we're here all the time. We're not working on our project, right? So.
Yeah. I mean, the decision that we've made is we want to have, so we've set up a rotation so that it doesn't feel like an interruption to engineers or folks on developer relations. And, we can't guarantee that we'll answer every message as soon as it's asked, but between other members of the community, kind of answering questions for each other and picking up some of that load, and then us kind of coming around at least a few times a day to answer those questions and to review. We feel like we found a balance that's working for now. Now, the community is growing super fast. We have well over 100 people joining every month. And so I don't know how long that will be sustainable, but it also leads to better documentation, kind of smoothing out rough edges in API design and things like that. And so my hope is that we'll be able to productize a lot of that and get to a place where it's much more self-serve.
So one thing you didn't mention, which I'm pretty sure you guys probably do this, which is basically you instrument your documentation so that you know what people are reading.
We actually have not done a ton of that. There are some hooks there. We can get traffic. We've been using Read the Docs, which is okay about giving you analytics. We've gotten more by adding like a tracking pixel for Google Analytics. But honestly, we haven't spent a ton of time in there. It's more qualitative feedback from people.
How would you rate your documentation at this point?
Oh, that's a sensitive question. I'd give us a B+. I think we cover most of the important concepts. We're pretty good about pruning stale docs or kind of pointing people towards workflows where workflows have changed.
So can someone go into the docs and get up and running without much hand holding, in your experience?
In most cases, but not all cases. That's why I wouldn't give us an A yet. There are a few places where there's sort of a moving front on abstraction design, or I won't even call them edge cases, but like combinations that we haven't fully addressed in the docs. And again, that's what Slack's for. That's why we welcome feedback there.
And what is the geographic breakdown of the community?
I don't know off the top of my head. Anecdotally, a lot in the US, of course. And then we seem to, for whatever reason, have pretty big contingents in the EU, especially around Germany, and then India as well. But I could be somewhat off on that. That's not based on like close scrutiny of data. It's mostly just impressions from talking to people.
So what's in the near-term roadmap of Great Expectations?
So for those who've been following very closely, we released the O13 release last fall, so end of November. We released that as an experimental release and have been sort of cautiously encouraging people to migrate, but not full force there. Pretty soon we will have all the rough edges sanded off there, and we'll be just encouraging people to move there entirely. That opens up some really cool concepts. For example, the notion of a batch as like a Mises slice, so like a well-partitioned slice out of logs or data warehouses or something like that. It gives you some strong guarantees on tracking the change in metrics over time. That in turn unlocks some really cool stuff around data profiling, allowing us to do things that look a lot like anomaly detection, but don't become a black box. They let you kind of collaboratively build rules by looking at past history. But at no point do you have to turn that over to the computer and say, okay, judge my quality according to some kind of arcane internal metric that I can't understand. So both of those things are close on the roadmap.
So so when you say allows you to incorporate rules, so how exactly do you do that?
Let me take a simple example and then you can sort of extrapolate from there. If you're looking at something like the number of rows in that arrive in a table every day, like within a 24-hour period, once you have this concept of a batch where you can slice up data and have guarantees over making sure that your queries are universally querying the correct slices. And when I say it this way, like it's actually not that complicated to just do this as a SQL query. The thing that's complicated is making sure that it works across all of these different engines and across all these expectations without loss of generality. But conceptually, what you're doing is slicing up past history. And then there are a number of different algorithms you can apply. And this is, again, a place we're trying to be very transparent. Most of them are some variation on bootstrapping, where you say, here are the past ranges for this variable. And that could be number of rows, it could be percent of null values, it could be the number of the number of rows that don't match a specific regex. So any of those would fall into this pattern. So from there you can bootstrap and say, okay, most batches fall within that range. So let's pick sensible limits that won't give you very many false positives, but will still give you pretty good discrimination for whether that rule is being met.
Oh, so then the user will be given, so this is the normal range. You can set your alerts based on what we're giving you as the normal range. So the rule is the alert in this example.
Exactly. Well, but then play it out and say, for any given column or any given table, you probably have multiple different rules that you want to satisfy. And so you want to make sure that when you put all of those together, you're still getting a reasonable balance of false positives, false negatives.
Right. So how does that scale if you're starting to get into the hundreds of columns?
I mean, from a performance standpoint, it's not that hard to scale.
The alert fatigue and false positive.
Yes. So, I mean, really the way you solve that is you don't try and delegate it completely. Like, imagine that it's not a data quality system. Imagine that it's an intern that's running checks. Like, what you would want to do is you want to have a conversation with that person where each time they bring you results back, you talk to them and say, okay, yeah, I get this one. This one I don't care that much about. So let's just turn that into a warning. Tell me about it every month, but don't bother me about it on each run. And over time, you start to sift out and calibrate what's really important to you.
So this is all in the open source, this kind of UX?
No. So you.
This is where the company comes in.
Yeah, that's exactly right. So you can do all of this in open source, and we've actually seen some pretty cool things that companies have built. And we don't believe that everybody should have to build that for themselves. When we talk about having a product on top of open source, it's basically good UX for marshaling all these things and making them fit together, just making it more convenient.
Right. Have you guys done anything about my my least favorite field in a table, which is the free form text. You know how many people, when they have forms online, they may ask for a company name and then it's free form text. Oh man, what a mess that field is.
Yep. Well, I don't know that we could say like we've solved that problem, but even there, like there are a lot of things you can attach to it. So, is there leading or trailing white space? Like, okay, that's a little one. It's just one glitch, but like that's the source of many frustrations. You can also do some really cool stuff with regexes. We haven't done it yet, but you can also do some cool stuff with fingerprinting using recurrent neural networks to say probabilistically, does this look like a name? Does this look like an address? So yeah, that's a place where I don't think we're going to like 100% solve that, because at the end of the day, typos will be typos and people will fat finger things. But you can start to actually let me introduce another
So
idea.
let me ask you this: so where does is there a boundary where you say, oh, that's now you're starting to get into entity resolution? That's beyond the scope of the project.
Yeah. So the way we think of it is entity resolution is eventually within the scope of the project, as long as the participants can assert clearly what an entity is. So if you can build that as an expectation or as an assertion, then yeah, like you should be able to build expectations that way. And we do see that. We see people building custom expectations that have fairly complex logic for, does this ID meet certain criteria? Or does this, like, and when I say complex logic, that could be a lookup to another internal database, or multi-line, multi-step function that goes through several different branches of logic. And the way we think of it is expectations are, if you kind of peel the layer back, they're asking questions, like factual questions of data. And if those factual questions can be reduced to code, then you can deploy it as an expectation.
By the way, so scale. So great expectations is not actually, so for example, you can use great expectations in using various execution engines like Snowflake and other things. So you folks are not actually doing the computation.
Yes, if you want to be very precise about that, the way I'd say it is, we compute metrics on the execution engine side. So as much as possible, we push the compute into Spark or into Snowflake.
So, but as an end user, it's the same API for great expectations across all these. Yeah.
It is. Well, but I also want to be fully transparent, just so people don't come away with slightly incorrect idea. In some cases, like for example, calculating KL divergence over histograms, you don't actually want to do the last step of that computation in Snowflake. What you want to do is you want to bring back binned values and then calculate some of that in Python on your side. So there is some compute that lives locally, but it like we're constructing it in such a way that it's not the stuff that has to scale up.
But it's architected smartly in the sense that if you can do it elsewhere, as long as my experience as a developer is fairly consistent.
Yes. And while we're on the topic of scaling, we actually haven't talked about this publicly, but in that O13 release that I told you about last November, we actually built in the hooks to be able to do automatic downsampling if you want. So if you want to assert quality tests on a sample of your data, not every single row, and there are actually a surprising number of use cases for this, you can do that. It's not documented yet, it's just in the code, but it does exist there. And there's actually some pretty cool things we'll be able to do with that in the future. Very
cool. So in closing, so what is the, so you said 100 contributors. Does this cut across industries, or is it mostly our friends in tech?
So I think the people using great expectations tend to be kind of tech forward. They're thinking about trends. They don't just want to do data the way it's been done before. But there are people like that in all kinds of industries. Like you don't have to live in San Francisco or New York to be tech forward. So there are a lot of big multinational Fortune 500 companies, lots of smaller companies too.
Well, what about the industry that you originally was working in healthcare, or have they embraced this?
We see a fair amount in healthcare. Actually, if I could zero in on one slice, the pharma industry in particular, there are a lot of really interesting
Really?
things going on in data.
So
Yeah.
what are they using Great Expectations for? Like what kind of
Oh,
data?
well, you name it. But like
Yeah,
in pharma, it's either research data, so making sure that drugs work as expected. And there are actually a lot of fairly complicated data aggregation, data normalization problems there. And you've really got to get it right because you're going to send it to the FDA, and
I see.
changing data, even minor amendments, are a big deal there.
Could get you in trouble.
Yeah.
But
There's also a lot
I
on
guess
clinical
yeah.
trials and
That's
marketing.
that's one thing we didn't discuss is there's actually regulatory beyond the responsible AI aspects. There's also the regulatory aspects of data quality,
Mhm.
right?
Well, I mean, if you want to zoom out from that, when we say data quality, I think a lot of people come to that from an engineering lens, and they think like, does it match a spec? But when you look at how organizations, not just individual engineers, use it, data quality is really like, does this data do what I think it does? Like, can I understand it? And
Or
that's not just an engineering concern.
can I use this to make decisions? Is it high
Yes.
quality enough so that if I decide to open a new branch in this address, it was based on quality data,
Yes.
right? So
Yeah. So, and I think that's for, at least for me and the rest of the Great Expectations team, a lot of our interest in this problem is how it's not just an engineering problem, but really a communication problem, right? It's about making sure that people who are never going to get into the guts of the code and shouldn't have to, can still have the assurance that their data is doing what they think it does.
by the way, I have a funny story about data quality. Actually, my first job after academia was as a quant in a hedge fund, where I was
Mm,
designing models for trading options and futures. And some options are so thinly traded, the data is quality is not very high. But
uh-huh.
back then, I think this is actually still the case. You can actually call Bloomberg and say, "Hey, I think this data is wrong," and someone will pick up the phone and fix it. Because from Bloomberg's perspective, data is something it's important to them because that's their clients depend on it, and so they will fix it.
Mm-hmm.
But that was, it was just basically something you would spot, and you can call someone. And they would actually fix it, which would always surprise me. Whoa, someone answered the phone. Uh, but I guess to the extent that people depend on data, I think the types of tools that you're building are going to be kind of, I would say, standard in a toolbox of companies and data teams.
I think so. I think this is one of these layers that you just need. And we've reached the point where it doesn't make sense to build it for yourself, right? Like, use an open source tool. Like that's what we're here for.
Yeah, I mean, you can build it for yourself, but you should be probably focusing on things that help the business
Yeah,
direct.
absolutely.
Yeah.
And I mean, when you look at the things that we built in, the ability to compile the docs, increasingly the ability to profile data and generate tests and docs, mostly, I won't claim it's ever going to be fully automatic, but mostly automatic from that. Like, those are things that just would not make sense for any individual team to do, but they're so nice to have once you got them. So that's the value we provide.
So what's the boundary between the project and monitoring?
Um, Unpack that for me a little more.
Well, I mean, like you said, it's mostly batch, right? So monitoring data quality in real time. Is that something you guys will do at some point?
Oh, I think so. I mean, if you look at what, again, Materialize and KSQL are doing, you can apply SQL or SQL-like interfaces to windows of data as it arrives. That's going to be a very natural fit for us.
But yeah, and that's something that you folks will need to do because people will increasingly want that, right?
Yes. I think it's going to be really interesting to see how the real-time data world plays out in general. Like, I see a lot of activity there. And it feels like this is different from many other places, but it feels like the tech is actually substantially ahead of pickup from the industry right now. And so it's going to be interesting to see if operationally the data teams and kind of the rest of the teams around the world
Yeah,
are able to keep up with that stack.
yeah, I think maybe not on the machine learning and modeling side, but I think basically even on the dashboard side, business users are more demanding these days, right? So in terms of they want more just-in-time dashboards and things like that.
Yes.
Yeah.
Yes. I mean, between you and me, I think some of that is window dressing, and it's not actually as urgent as some business users make it. But I think it actually is a pretty good stress test for data
Well, no,
systems, right? Like,
I mean,
it's a hard problem.
Abe, if you're doing online marketing and you launched a campaign 2 hours ago, you want to start seeing if it's working, right?
Yeah, no, that's fair. I think there are a lot of other. I've seen use cases like that where when you say, "Well, what action would you take?" The action is, "Well, at our meeting in 2 weeks with the vendor, then we would change X." It's like, why do you need a real-time dashboard for a decision that only gets made once a month?
By the way, don't sleep on Pulsar. It's a good project. Apache Pulsar.
On what?
Apache Pulsar.
Oh, okay. I haven't been following it. I have been sleeping, I guess.
Yeah. And with that, thank you, Abe Gong.
Thanks, Ben. It's been a pleasure.